بسم الله الرحمن الرحيم. الحمد لله رب العالمين، والصلاة والسلام على سيدنا محمد وعلى آله وصحبه أجمعين. Good morning, my dear students, and welcome to the second part of Chapter 5, in which we continue by explaining the two remaining free solutions regarding to cloud computing, and which are Open Nebula and Eucalyptus. For Open Nebula, in fact, it's an European project and was developed by a Spanish company in 2008. It's an open source cloud solution under, for sure, the Apache license, and also written in C++, Ruby, and Shell. The main objective of Open Nebula is to provide a set of functionalities that organize the operation of a set of physical servers, providing resource to so-called virtual machines. So, how to use Open Nebula as a cloud service provider? Cloud service providers are out there everywhere. It doesn't just refer to web hosting or virtual private server companies anymore who are offering virtual machines to their clients. Even inside large enterprises, there are teams or departments that support the internal infrastructure for their users and staff. No matter what kind of service provider you are, there are some features that you absolutely need your cloud management platform to have. Today, we will explore, inshallah, new features of Open Nebula and how to use it as a cloud service provider. These features can be summarized. First, the multi-cloud, the multi-tenancy, billing and showback, service as standard, tons of customization, and simple, intuitive user interface. Let's explain the first feature, which refers to multi-cloud. So having to log into multiple different portals to provision workloads of different systems is a total nightmare, as we all know. Whether you want to offer virtual resources on, for example, VMware, KVM, and so on, or perhaps a mixture of all this, users can build and manage these resources with a single set of credentials. So thanks to Open Nebula, simple, intuitive, graphical user interface. There may also be times where you want to quickly provision a new private cloud cluster for a client. This can be done really easily in Open Nebula 2. But there is more. You can also use a similar approach to expand your private infrastructure by provisioning additional on-premise resources whenever they become available or whenever you need them. This is for the multi-cloud. The second feature is about the multi-tenancy. So having a multi-tenant cloud management platform is an absolute requirement for service providers, where you can provide your customers with their own credentials to log in and manage their resources. OpenNebula features a user and group system that allows you to define separate customers which have multiple users. The ability to share virtual machines and resources between your different users in the same company is really important for larger organizations. The third feature is about the role-based access control. OpenNebula doesn't use a standard RBAC system, which refer to the role-based access control. However, it uses a concept of view that provides much more control over exactly what your end users and customers can and cannot see. So you do this by assigning a single or multiple views to a group of users, which controls which tabs they will all be able to see. For example, you can remove certain pages from the view so your clients cannot access them. It's a lot more verbose than that. In fact, you can either go as far as to customize exactly which columns and tabs are shown on specific page. The fourth feature is about billing and showback. So being able to put a price on your resources is really important, as well as providing this information to your end users and customers when they are creating or editing existing workloads. OpenNebula handles pricing inside of templates, where you can assign hourly pricing to CPU, memory, and disk resources. OpenNebula handles all of the calculations to determine how many hours a workload has been online for, and allows all of the data to be exported in other formats, such XML, JSON, and CSV formats. Feature number 5 is about self-service as standard. OpenNebula has been designed with the end user in mind, allowing lots of options to serve their own resources. So self-service is almost a requirement for any cloud management platform out there. But OpenNebula takes it to the next level, not only allowing you to self-serve virtual machines and templates, but also to provision your own virtual networks as well. System administrators can create network templates in which your end users can then consume in order to create their own private networks based on the physical infrastructure you define in the template. You can turn the network template to automatically assign a VLAN ID and pass a list of pre-configured VLANs to a configuration file. OpenNebula will then create a VLAN target network automatically without any need for the administrator to spend time on these tasks. Network templates also apply for VMware backend networks as well. Whether you are using, for example, the NSXV or the NSXT or standard networking within vCenter, OpenNebula will automatically create a standard vSwitch or DVSwitch based on how you configure the template. Feature number 6 is about the tons of customizations. Being an open source product, almost every aspect of OpenNebula can be customized. From the logo you see in its top right hand corner through its graphical interface to advanced ways to inject your own customizations to the new virtual machines, LXC system containers, or Firecracker micro virtual machines that your end users and customers will be using. The OpenNebula contextualization system is second to none, allowing you to write your own scripts to run on first root. This could be something as simple as updating the operating system, adding SSH keys, or installing agent and custom software. Also, you can use your own preset variables, ask for user inputs, or when building multi-virtual machine applications, in which we call them services, you can automatically retrieve data from the parent or child virtual machines to offer even more customization options. The last feature is about simplicity and intuitivity user interface. OpenNebula frontend, which is called Sandstone, has a dedicated view intended for end users. So the cloud, which is called the cloud view. Sandstone's default view is perfect for administrators, allowing them to see anything and everything, even as far as raw data received from compute nodes and monitoring data. For end users, the cloud view is important as it simplifies their user experience and also providing an easy-to-use interface that displays just the information they would be interested in. Users can expand their workloads, view performance metrics, and of course, enjoy all of the standard virtual machine management functionalities, including starting, stopping, and rebooting virtual machines, as well as accessing responsive console without any third-party software required. Whether you are using Sandstone as an end user or an administrator, you get a super fast and responsive user interface with a single page application, providing a great user experience. This is mainly the 6 main features of OpenNebula. In fact, OpenNebula combines existing virtualization with advanced features for multi-tenancy, automatic provision, and elasticity to offer on-demand applications and services. For example, it supports both KVM, virtual machines, and Kubernetes clusters in a common shared environment controlled by a single entity. Second, it can easily provision hybrid and edge environments with infrastructure resources from Amazon Web Service and Equinix. 3, it provides a single, feature-rich, and flexible management platform for all cloud components across data centers by reducing complexity, resource usage, and operational costs. Now, let's explain the distributed cloud architecture related to OpenNebula. A standard OpenNebula cloud architecture consists of the cloud management cluster with the front-end nodes and the cloud infrastructure compromising one or several workload clusters. This can be distributed across multiple geographical locations with different configurations and technologies to better meet your needs. For example, first, edge clusters that can be automatically deployed both on premises and on public cloud or edge providers to enable true hybrid environment. Second, open cloud clusters based on certified combinations of open source hypervisors, storage, and networking technologies. Three, Kubernetes cluster automatically deployed through Open Nebula CNF certified distribution by integrating seamlessly with virtual machine workloads. This is all about Open Nebula. Now, let's move to the last free solution, which is Eucalyptus. Eucalyptus is a platform used by Amazon EC2. It allows the installation of a private and hybrid cloud infrastructure. In fact, it's written in Java, C, and Python. Eucalyptus is a Linux-based open source software architecture for cloud computing, and also a storage platform that implements infrastructure as a service, which is known as IWAS. It provides quick and efficient computing services. Eucalyptus was designed to provide services compatible with Amazon's EC2 Cloud and Simple Storage Service S3, which was explained in the past chapters. Eucalyptus is, in fact, a powerful open source tool for building private clouds. So if you are looking to understand how it fits into cloud-based development practices, you can do that through some free courses available on YouTube. Now, let's explain the Eucalyptus architecture. Eucalyptus can handle Amazon Web Services and their own private instances. So clients have the independence to transfer cases from Eucalyptus to Amazon Elastic Cloud. The virtualization layer oversees the network, storage, and computing. Occurrences are isolated by hardware virtualization. Here is some important features of eucalyptus. First, for images, it's a good example, or a good example is the Eucalyptus machine image, which is a module software bundler and uploaded to the cloud. Second, instances. When we run the picture and use it, it turns into an instance. 3, networking. It can be further subdivided into 3 modes: static mode, system mode, and managed mode. For the static mode, in which we can allocate IP address to instances. For the system mode, by assigning a MAC address and input the instances network interface to the physical network via ANSI. For the managed mode, it achieves local network of instances. 4, access control. It is used to give limitations to client. 5, elastic block storage. It gives block level storage volumes to connect to an instance. And finally, auto scaling and load adjusting, which is used to make or obliterate cases or administrations depend on necessities. This is the main features or the important features of Eucalyptus. Now, let's explain the components or the architecture components of Eucalyptus, and which can be summarized in 4 main components: node controller, cluster controller, storage controller, and cloud controller. What we mean by node controller? Node controller is the life cycle of instances running on each node. It interacts with the operating system, hypervisor, and cluster controller. It controls the working of virtual machine instances on the host machine. The second component is cluster controller. It manages one or more node controller and cloud controller simultaneously. It gathers information and schedules virtual machine execution. The third component refers to storage controller, which allows the creation of snapshots of volumes. Persistent block storage over virtual machine instances. So, storage controller is a simplified storage system. It stores images and snapshots and stores and serves files using S3, which is the Simple Storage Service APIs. The last component is cloud controller, which is the front end for the entire architecture. It acts as a component web services to client tools on one side and interacts with the rest of the components on the other side. This is mainly the main components of Eucalyptus. Now, let's explain the operation modes of Eucalyptus. The operation modes of Eucalyptus can be summarized in 4 modes, which are the managed mode, the managed no VLAN mode, the system mode, and the static mode. For the managed mode, numerous security groups to users are, or as the network is large. Each security group is assigned a set or a subset of IP addresses. Ingress rules are applied through the security groups specified by the user. So the network is isolated by VLAN between cluster controller and node controller, and assigns 2 IP addresses on each virtual machine. The second mode, which is the managed node. The root user on the virtual machine can snoop into all the virtual machines running on the same network layer. It does not provide virtual machine network isolation. The third operation mode, which is the system mode, and which is the simplest of all modes. In fact, a MAC address is assigned to a virtual machine's instance and attached to node controller's bridge Ethernet device. The last mode, which is the static mode, and which is similar to system mode, but has more control over the assignment of IP address. So MAC address or IP address pair is mapped to static entry within the DHCP server. Now, let's explain some advantage of Eucalyptus Cloud. First, Eucalyptus can be used to benefit both the Eucalyptus private cloud and the Eucalyptus public cloud. Second, examples of Amazon or Eucalyptus machine pictures can be run on both clouds. 3, its APIs is completely similar to all the Amazon Web Services. 4, Eucalyptus can be used with DevOps apparatus like Chef and Puppet. 5, also it isn't as popular yet, but has the potential to be an alternative to OpenStack and CloudStack. 6, it is used to gather hybrid, public, and private clouds. And finally, it allows users to deliver their own data centers into a private cloud and hence extend the services to other organizations. So this is mainly the advantage of Eucalyptus. Now let's explain the main or the key challenges in cloud, and which can be summarized in a lot of challenges such as security, performance, availability, difficulty of integration with IT, lack of customization, higher costs for confusing clouds, lack of trusted providers, migration issues, server consolidation, scheduling, interoperability, and integrating difficulty with internal systems. What about security or data security and privacy? So when working with cloud environments, data security is a major concern as users have to take responsibility for their data. And not all cloud providers can ensure 100% data privacy. No identity access management, lack of visibility and control tools, data misuse, and cloud misconfigurations are the common reasons behind cloud privacy leaks. There are also concerns about, for example, malicious insiders, insecure APIs, and neglect or oversight in cloud data management. So what is the solution? The solution is to install and implement the latest software updates as well as configure network hardware to prevent security vulnerabilities. Also, using antiviruses and firewalls, increasing bandwidth for cloud data availability, and implementing cybersecurity solutions are some ways to prevent data security risks. The second point is about the multi-cloud environment. Multi-cloud environment present issues and challenges such as configuration errors, data governance, lack of security patches, and no granularity. It's difficult to apply data management policies across various boards while tracking the security requirement of multi-clouds. So what is the solution? The solution is to implement a multi-cloud data management solution which can help you manage multi-cloud environments. So here we should be careful while choosing the solution, as not all tools offer specific security functionalities, and multi-cloud environments continue to become highly sophisticated and complex. The third point is about performance challenge. So for performance or the performance and security of cloud, solutions depend on the vendors. And keep in mind that if a cloud vendor goes down, you may lose your data too. So the solution is cloud service providers should have real-time SaaS monitoring policies. The other challenge is about interoperability and flexibility. In fact, when you try to shift application between two or multiple cloud ecosystems, interoperability is a real challenge. Some of the most common issues are, for example, match the target cloud environment specifications by rebuilding application stacks, managing services and applications in the target cloud ecosystem, working with data encryption during migration, and configuring network in the target cloud for operations. What is the solution? The solution is, before starting work on projects, setting cloud interoperability as well as portability standards can help organizations solve this problem. So the use of multi-layer authorization and authentication tools is a good choice for account verifications in hybrid, public, and private cloud ecosystems. Other challenge, which is about the dependency on network. So when transferring large volumes of information between cloud data servers, a lack of sufficient internet bandwidth is a common problem. So there is a risk of sudden outage, and data is highly vulnerable. So to help prevent business losses from sudden outage, enterprises should ensure there is high bandwidth without sacrificing performance. So what is the solution? The solution is to focus on improving operational efficiency and pay more for higher bandwidth to address network dependencies. Another challenge is about the lack of knowledge and expertise. In fact, hiring the right cloud talent is another common challenge in cloud computing. There is a shortage of working security professionals with the necessary qualifications in the industry. As the workloads are increasing, so are the number of tools launched in the market. Enterprises need good expertise in order to efficiently use these tools and look out for the best fit. So here the solution is to hire cloud professionals having specializations in DevOps as well as automation. The other challenge also is about reliability and availability. So high unavailability of cloud services as well as lack of reliability are the major concerns in these ecosystems. So in order to keep up with ever-changing business requirements, businesses are forced to seek additional computing resources. If a cloud vendor gets hacked, the sensitive data of organizations using their services gets compromised. So the solution is to improve both aspects by implementing the NIST framework standard in cloud environments. Also, we have another challenge which is related to password security. So account managers manage all their cloud accounts using the same passwords. Password management poses a critical problem, and it's often found that users resort to using weak and reused passwords. So the solution is to secure all your accounts by using a strong password management solution. To further improve security, in addition to a password manager, use, for example, multi-factor authentication, which is known as the MFA. So, cloud-based password managers should alert users of security risks and leaks. Also, we have another challenge, which is about the cost management. Also, cloud service providers offer a pay-as-you-go subscription model for services. Hidden costs are charged as underused resources in enterprises, making the costs can add up. So the solution is to implement resource use monitoring tools as well as auditing systems regularly are some ways organization can fix this. It's one of the most efficient methods to deal with major challenges and manage budgets in cloud computing. We have also the challenge of lack of expertise. Cloud computing is a highly competitive field, and there are many professionals who lack the required knowledge and skills to be employed in the industry. There is also a huge gap in supply and demand for certified individuals and many job vacancies. The solution is that companies should help existing IT staff in upskilling their careers and skills by investing in cloud training programs. We have also another challenge, which is about the control or governance. So good IT governance makes sure that the right tools are used and assets get implemented as per procedures and agreed on policies. The lack of governance is a common problem in cloud computing, and companies use tools that do not align with their vision. So IT teams don't get total control of compliance. Also for data quality checks and risk management, thus creating many uncertainties when migrating to the cloud from traditional infrastructure. The last challenge is about compliance. So when it comes to having the best data compliance policies, cloud service providers are not up to date. So organizations run into compliance issues with state laws and regulations whenever a user transfers data from internal servers to the cloud. So the solution is that the General Data Protection Regulation, known as the GDPR, is expected to address compliance issues in the future for cloud service providers. So this is what we have in the second part of chapter 5. Thank you for your listening, and assalamu alaikum wa rahmatullahi ta'ala wa barakatuh.